All right, let's figure out both the energy and the wavelength of an atom with a frequency of 40 megahertz. Okay, really simple. Energy equals hv. H is Planck's constant, v is frequency. Using Excel, I just type equals 40. Now what's mega? E to the sixth. That's a million. Okay, that's 40 megahertz times Planck's constant, which is 6.626 e to the minus 34. There we go. That's the energy. Minus 34, excuse me. E to the minus 34. All I do is write E and then minus 34, and there's the answer. That's the energy. Okay? Now, I look at the equation here, where I see energy is a bridge between frequency, the V here, and the wavelength, which is like an upside down Y underneath here. Okay, so I'll just put in the energy value, 2.65 times, I'll write it out, 10 to the minus 26. And there we go. I got the equation set up. Okay. Now I got to get lambda here. Let me make it bigger so it stands out. I got to get lambda on top. It's underneath right now. So what I do, multiply both sides by lambda, and it'll cross out here. Just give me a line here. So this cancels out. All right. And let me clean that up now. So that cancels out. So I'm left with lambda equals hc, and I'll make hc bigger. Hc is just Planck's constant times the speed of light. Okay. So lambda times the energy, 2.62, 2.65 times 10 to the minus 26 equals hc. So what is hc? Well, it's just Planck's constant, 6.626. I'll make it bigger. Let me make it a little bit larger here. So hc is what? 6.626 e to the minus 34 times speed of light, which is 3 e to the 08. Wait, times 3 e to the 08. And I got to put it in scientific format. Cells, scientific. There we go. So that's the energy. That's hc. Make it a little bigger here. So I have set up lambda times this number equals 1.99 times e to the minus 25. Right? So now I got to get lambda alone. I got lambda times this number. So all I do is divide both sides by this number. 2.65 times 10 to the minus 26th. So it's really, let me write it out neater now. So I've got, let me sort it. I've got lambda equals, lambda times that number equals 1.99 times e to the 25th. So divide both sides by this number to get lambda alone. Lambda's not alone yet. Okay, on the left, 2.65 e to the minus 26. And on the right, divide it as well. Now in Excel, it's really easy. Right, so it's going to cancel on the left. Let me just cancel that out. So this is going to cancel here, right? So I'll delete that. So lambda alone, lambda equals just this quotient. Let me make that equal sign a little neater. Equals this quotient, 1.99 e to the 25 divided by 2.65 e to the minus 26. In Excel, it's really easy to do that entire calculation at once. It's just 1.99 e to the minus 25 divided by 2.65 e to the minus 26. And it's 7.51. So the wavelength equals 7.51 meters. And that's the final answer. 7.50, whatever, 09, It's going to round it off. separate it here. So that's how you use Excel using the what I call the E functions. Makes it much easier than a calculator. Okay, I hope that was helpful.